Okay, we have a physics problem, and this is how it goes. We have an airplane that's flying horizontally with a speed of 480 kilometers per hour. It's 100 meters above the ground, and he wants to drop a package in a way that it will come and land exactly on top of this tank. The top of the tank is 2 meters above the ground. So what they want us to find is the distance from the time where the pilot drops the package all the way till the instant that it hits the top of the tank. And in the second part, they want us to find the speed at which the package will hit the top of the tank. Now, our axis of we're gonna have x0 and y0. We're gonna position it right here at the location where the package is released. So this will be my x-axis, and this will be my y-axis. There you go. So at this point is my x0, 0, y0, 0. My final y will be negative 98 meters, since it starts at 0 and the ground is at a negative 100 and the top of the tank is 2, so 100 minus 2 will be negative 98. We are going from 0 downwards. If we do it this way, it's easier to calculate. Okay, that's how we got the 98 meters. Now, the velocity of the package at the instant that it's released, the velocity of in the x direction, so Vx0 is 480 kilometers an hour, but we're gonna need this in meters per second. So there you go, we calculated that, 133.33 133.33 meters per second. Ooh, that was hard to say. Okay. Velocity in the y direction at the moment that it's released is 0. And we also know gravity, which is 9.8 meters per second, but we are using it with a negative downward. Okay, and the first part, they want us to find x, which is right here, from here to here. Since this is a kinematics problem, we're going to be working with these formulas, and we're going to be using the one that I marked here as number 2. And first of all, we're going to work in the y dimension, so we're going to replace all the x's with y's. So I'm going to rewrite my formula with consideration for the y dimension. So y equals y0 plus v at y0 times t plus 1/2 gt square. Now let's take a look at what we have here. We have y0 will be 0. Over here we're gonna have a 0. Maybe I shouldn't put this close. We're gonna have 0, and this is the only term left. So this is what we're gonna be working with. Y equals 1/2 gt square. Okay, we can go ahead, solve for our t, and plug in. T equals the square root of y over 1/2 g. Let's go ahead and plug in. Y is negative 98 meters, and over here 1/2 of g we can calculate to be negative 4.9 meters per second square. With a calculator we can go ahead and calculate this, and we will get a 4.472 second. Now, we found time, and this will help us to connect to the x dimension, and we're gonna start working there. Now, in the x direction, we do not have acceleration. So, a in the x direction is 0 meters per second square. We're gonna use the same formula again, the number 2. And this time we're gonna use it just like that, with the x dimension. So x equals x naught plus v naught t plus 1/2 a in the x direction t square. Like we said, this term goes to 0, so all we have left to work with is x equals x naught plus v naught t. And just to be accurate, this is our vx naught. Let's not confuse it with nothing else. In the x direction, x naught. Now, we have our formula. Let's start plugging in. X naught, again, we could have cancelled it out here because it's 0. So, there you go, 0 plus v in the x direction, v naught, it was 133.33 meters per second, and times the time value that we found right here, 4.472 seconds. Now, with a calculator, we can find the value, and that's gonna be 596 meters. We can go to 3 sig figs, and there you go. We found our value in the x direction. Okay, this was part A. We found the x that they were looking for. Now they want us to find the speed at which the package will hit the top of the tank. So I'm gonna mark it as v equals question mark. Final velocity of the package right before impact. So let's do a little visual representation of what exactly is gonna happen here. We have the package that's traveling somehow in this direction. Let's see, let me use a different color. So it's coming somehow like this. Alright, this is the way it's going, and this is where the package, let's say, it hits the top of the tank. So this is our V. This is what we are looking for. This one has components, and here this is our Vx, and this one coming downwards is our Vy. Okay, and now we're gonna calculate the components, and from there we're gonna be able to find our final V. That's the one we're looking for right here, this bad boy. Okay, we are working with our kinematics formulas, and this time we're gonna use the one that I have marked here as number 1. So V equals V naught plus AT, but we are calculating, let's go first for the Vy. So this will be my Vy, Vy naught, A in the y direction, and A in the y direction is our G, and the time. Now, Vy naught, we know it's 0, so all we have left is Vy equals GT. This is what we have to plug into. Vy equals negative 9.80 meters per second square times, and the time is the same one that we found earlier, which is 4.472 seconds. With a calculator, our value is found to be 43.8025 and 6 meters per second, and this is a negative value from there. Let's not lose that. Negative, and it going downwards. Okay, we found our y component. Now let's take a look at our x component. We need vx. Now, as we said earlier, acceleration in the x direction is 0. There's nothing accelerating it or slowing it down in the x direction. We are ignoring air resistance, so there you go. Acceleration 0. So our final velocity will be the same as our initial velocity. Our initial velocity was 133.33 meters per second. That does not change. Now, using our friend Pythagorean, we're gonna use his formula and find our v. Okay, from here we can apply this to our component triangle, and from here we can find that our v that we are looking for is equal to the square root of, let's see, what did we find? 133.33 meters per second square, and this whole thing on the square, plus, in parentheses, this one, which is negative 3.8256 meters per second on the square. And over here I made a mistake. There's no square over here, just meters per second and meters per second. There you go. With a calculator, let's go ahead and find it. It's gonna be 140.4 meters per second, and they want us to find the speed. So if we would have found the negative value here, we would just ignore it. Speed doesn't have direction, and let's round it to 3 sig figs, so 140 meters per second. And there's our second value. Thank you for watching. Like the video if you found it interesting, and please subscribe.